In this lesson, we're going to be solving this problem. This problem is under the drive shaft. The problem reads as follows. An electric motor shaft has a diameter of 25 millimeters and the length of 700 millimeters. An angle of twist of 2.5 degrees is observed when the loaded shaft rotates at 1200 revolutions per minute. The modulus of rigidity is 85 GPa. Calculate the power, calculate the shear stress. Here, we've got the diameter, here, we've got the length, we've got the rotational speed, we've got this modulus of rigidity, and we've got the angle of twist. Let's write all these, the data we have here. We've got the diameter, it is 25 millimeters, of which is 0.025 meters. Then we've got this angle of a twister. Let's convert it into radians. So it is 2.5 degrees. You divide by 57.3. Then we have the length here. The length is 700 millimeters, of which it is 0.7 meter. Then we've got the rotational speed, which is 1200 rotation per minute. Then we've got the modulus of rigidity, it is 85 times 10 to exponent 9 Pascal. Then we have to calculate now the power, the stress. The power formula, it is P is equal to 2 pi times rotational speed times the torque divided by 60. This 60 is for converting this to be revolution per second. Then here we've got the rotation speed. What we don't have is this one, the torque. To find the torque, let us try two formula to find the torque. The first one, it's a torque is equal to a pi divided by 16 times the shear stress here and the diameter to the power 3. Here we don't have the shear stress here. Therefore, we will not use this one. Then let us try the angle of a twist formula. It is the angle of a twist is equal to 10.2 times the torque that we are looking for times the length, all divided by a modulus of rigidity times the diameter to the power 4. So here we only have one unknown. It is this, the torque. We have this length here, it is, we have the diameter, we have this, then we have this. So we can use this formula to find the torque. That torque will use in this formula, power formula, to find the power. So let us substitute here. Then the angle of a twist, here it is, let us write it. It is 2.5 divided by 57.3 is equal to this 10.2 times 10. Then the torque that we are looking for times the length, it is 0.7, all divided by a modulus of rigidity. It is 85 times 10 to exponent 9. Then times the diameter, which is 0.025 to exponent 4. Then here we've got only this unknown. So when you solve all this, it's gonna give you torque to be 202.8. Then the units here for torque. So you've got now the torque. Let's come this side to substitute the torque in the power formula. It is power, then 2 pi, then the rotational speed, it is a 1200 then times that torque we got now here, or it is 202.8, all divided by 6. That 6 is to convert this 1200. All this gonna give you 25.49 kilowatts. That's the power that we've been looking for here. First, now we have found the power. Now we have to find the shear stress. We have to use this formula. Then let's write it. It is torque is equal to pi divided by 16 times the shear stress times the diameter to the power 3. We have to make this shear stress a subject of the formula. This shear stress, it is equal to a torque times 16 all divided by pi times the diameter to the power 3, like this. Then from here we will substitute the torque. We found it 202.8, then times 16 all divided by pi times the diameter is 0.025 to the power 3. Then from here we get the shear stress to be 66.10 megapascal. This is 66.10 times 10 to exponent 6 Pascal. That's what we're required to find from the statement. Here we're given all these: the diameter, the length, the rotational speed, the modulus of rigidity, and also angle of a twist to calculate this power. Then the formula to calculate power, here it is. Then here to calculate the power, you will need the rotational speed, you will need a torque. Rotational speed and torque. So because we have the rotational speed but we don't have torque, we have calculated the torque from this formula to find the angle of a twist. Then here we find the torque. Here it is. We took it to substitute it here in power formula. From here got this 25.49 kilowatts. That's the power that we're required to find from the problem statement as a first answer. Then we're required to find the shear stress. Then we use this formula